What's going on, math people? All right, so today we're jumping into 2.1 rates of change, secant and tangent slopes. All right, heads up, all of these are slopes. Okay, so from algebra, we know that rate of change is denoted by this triangle, and it says the change in y over the change in x. Now, if we write that out in function notation, you have the change in the y values over the change in the x values. Now let's extend this algebra to calculus. Alright, let's move it on over. Let's say we have f of x1 plus h. We have that subtle change. That's the new x2, right? Minus f of x1 all over x1 plus h minus x1, and after simplification we have f of x1 plus h minus f of x1 all over h. Alright, so this is average rate of change. Alright, right now we're focusing specifically on average rate of change. Alright, average rate of change. So we're going to do an example that brings us from the calculus standpoint, and then we'll do another one from the algebra standpoint, then we'll do another one that's focusing towards calculus. Alright, so example. Suppose we have a function. It says find the average rate of change over a given interval. We have f of x is equal to the square root of 4x plus 1. On the interval, that interval, let's say we have 6 to 12. Alright, so anytime you see an interval, just have in your mind that the interval is over the x-axis. Alright, so that interval is focusing on the x values. So it gives you the x values that it wants you to use whenever you're coming from this algebra standpoint. Now let's calculate this. Alright, finding the average rate of change, we need the y values. We have the x values, now we need the y values for those respective x values. So I don't want to use the same color here, so allow me to change this over to black while I'm working out this example. Finding the y values, I'm going to input the x values. We have square root of 4 times 6 plus 1. That's equal to the square root of 25, which equals 5. And then we also have input value of 12, the square root of 4 times 12 plus 1, which equals square root of 49. That gives us 7. So our average rate of change in the y values, 7 minus 5, over the change in the x values, 7 was produced by 12, 5 was produced by 6, gives us 2 over 6. And that reduces to 1/3. What that tells us, we have one change in y for every 3 changes in x. Alright, now let's ease on over to this secant and tangent slope from that last portion of average rate of change. That portion right there is also known in algebra as the difference quotient. And if we toss a limit in front of it, in calculus, it would be known as the definition of a derivative. All right, so let's go ahead and ease on down to that. I'm just gonna toss it down here for us. F of x 1 plus h minus f of x 1 all over h. All right, let's move that up and do another example. All right, so, and this in algebra, again, this is the difference quotient, but still we're talking about average rate of change. And we'll use this to find those slopes. Find secant and tangent slopes at a point. Okay, we want to find secant and tangent slopes at a point. All right. So let's start off with a pretty cakewalk example. Let's do something like let me give me a different color. Example. Let's say we have f of x equals x squared plus 2. And we want to find the secant and tangent slope at the point of we'll say 3, 11. Okay. All right, so here we go. Let's go ahead and jump into the solving component. So we're going to apply what we got because we want to find the secant slope first. The secant slope contains an h. Whenever you go through the simplification, the secant slope contains an h. So what is x1? x1 is 3. x1 is 3. F of x1 is 11. All right, so now let's put this information in. We have 3 plus h squared plus 2. All we did was take x1 plus h and plug it into the original function. Then we say minus f of x1, which is the 11 that was given. And that will be all over h. All right, we're going to go through and simplify. Simplifying, we have 3 plus h times 3 plus h plus 2 minus 11 all over h. All right, the next thing, you go through and continue the simplification. We're going to double distribute there, and we'll have 9 plus 3h plus 3h plus h squared plus 2 minus 11 all over h. Next, we have combining like terms. 9 plus 2, that's 11, plus 6h plus h squared minus 11 all over h. You might be asking, why didn't I combine that negative 11 earlier? I want you to see that every time you do this properly, whenever you do these properly, that f of x1 should always cancel completely. And the things that remain should be only those things that contain an h. 6h plus h squared over h. After simplification, we have 6 plus h. Because h goes into 6h, that will reduce, that would be 1. 1 times 6 is 6, and then the other is a reduction of power. So what we have found is the secant slope. That is the secant slope. Alright. Now what is the tangent slope? The tangent slope is when we let h go to 0. So to find the tangent slope, is when we let h go to 0, and the only thing that remains is 6. Alright, so we have found the secant slope. Secant slope contains an h because there could be subtle movements there. Tangent slopes does not contain an h. Tangent slopes is let h go to 0. Now, what we'll also end up with, it might say find the equation for the tangent line to the curve. Alright? Find the equation for the tangent line to the curve. Pulling back some moves from, and here's more notes. I want you to recall the point slope form from college algebra. You're going to use this a lot, and I use a modified version. It's just what I like to do. So point slope, y equals the slope times x minus x1 plus y1. That's your point. Alright, so if it says find the equation of the tangent line for that same example that we just did, find the equation of tangent line, then you're going to use point slope, the point that you were given, and the slope of the tangent that you found. So we're going to go ahead and plug this information in. So we have y equals the equation, the value of the tangent slope is 6 times x minus the x1, which was 3, plus y1, which is 11. Equation found. That's in point slope form. If we simplify it on down to slope intercept form, you have 6x minus 18 plus 11, y equals 6x minus 7. Alright, so you see how it recalls algebra information. This is the equation for the tangent line. Alright, that right there should get us up and rolling. That's 2.1 in a nutshell. There, I will see you next time, my math people.